Okay.
Okay.
So let's start on question 3, yeah?
Yeah. While you're required to work together on this quiz, each member of the group must submit their own answer in order to receive, blah, blah, blah. You guys still there?
Mm-hmm.
Yeah.
Okay.
I'm just I'm opening up the file right now, the Excel
Okay.
file.
Oh, yeah, I should open that too. Given the linear regression equation, what is the intercept? Math stuff. Okay. Ah. Huh. Is that the same file we used last week? The
Yes, I
Excel
think so.
one? Okay.
So are we ready to go with question 3?
Yes.
Sorry, I'm having problems here with my Excel. It's like freezing up on me.
Mm-hmm. Well, we don't need Excel for the first 3.
Okay.
Okay. All right. Let's just go then. Given the linear regression equation y equals 2.0 plus 1.5 intercepts.
So if the intercept shouldn't be 1.5.
Nope.
Damn. Then 2.
Yeah, it should be 2.0 because it's the one that we're not multiplying by anything else, and it's
called the BO, right? Or B naught or something?
Yeah, B0, B0, BO, I don't know how you call it.
Yeah.
And then B1 is the slope.
Should we write 2.0 or just 2?
I wrote 2.0.
Good job, Daniel. Okay.
So
given the linear regression equation, same. What is the slope? 1.5.
Yep.
Given the linear regression equation, blah blah blah. What is the predicted value of epsilon of y? Sorry, yeah, y when x equals 16.
Epsilon in Italian?
Yeah, it just came out like that. Sorry. Okay, so what is the predicted value of y when x equals 16?
I came up with 1.
Just a moment. Everything's being really slow right now. We're on 5, right? That's 1.
Yes. Yeah, I think it's 1, 2.
Yeah, 1
Okay.
is 1. Yeah.
For the next 7 questions, use the data file, math self, blah, blah, blah. Be sure to use the confidence data for the explanatory variable and the score data as the response variable. Confidence. Oh. Okay.
Okay, when you're ready with the data, just
Sorry.
share.
This is taking- Okay, so I got y-intercept. I got for the y-intercept 1.296.
Sorry?
For the y-intercept, I got 1.296.
No, I didn't get that.
Did you? Okay, I took the score to the explanatory variable.
No, you put the score in the response variable.
Ah,
And you take the confidence and put it in the explanatory. Because like the study is to see how
oh, I got 18.690 for the y-intercept.
What did you? Oh, I can't hear. Can you guys say it again?
0.96 for the y-intercept.
you there?
Hello?
Yeah, I think
Okay.
the connection went down for all of us for a moment.
Yes. So, what is the y-intercept that you guys get?
Well,
Someone was saying.
Well, we first have to check for the scatter plot. You know, question 6 talks about
Yes.
the shape.
The scatter plot.
Yeah, the shape of the scatter plot.
I'm not good at reading those scatter plots, but the not a banana shape.
Yeah.
Okay, hamburger, like it just looks
it
like
kind of
looks like
follows,
anything.
but it kind of
Yeah.
follows, you know, like
It could
line.
be a hot dog, a fat hot dog.
Yeah, I would go with the hot dog because as values on the x-axis increase, they also increase in the y-axis.
Okay.
So I would say
So
that.
then what do you? So would a hamburger be more like just like horizontal?
Yeah, a hamburger is just a mess. You know, that just there's no correlation.
I mean, what I can see is that there is nothing on the top left of the scatter plot, and kind of nothing on the bottom right. So it seems to have the correlation.
Yeah. Also, if you look at the R, you know, that it's the coefficient that we saw last lesson. You know, it's 0.728. So there is correlation, and it's at least moderate. So I would go with hot dog shape.
Okay.
Yep. Shape of the scatter plot you produced in the last question. What can you say about the appropriateness of using simple linear regression to model these data? Simple linear regression is appropriate for these data. If simple linear regression is used for the data, the result will not be reliable. Simple linear regression is not appropriate for these data.
I'll say the first one.
Yeah, me too.
Yep.
Then how many observations are in the data? Observations. 2.
2 are the variables. Observations, you know, it sounds like how many times they how many tests they made, it looks like.
140 blah blah blah.
139 I have.
Yeah, 139.
I don't know, would you agree that that's what they're asking?
Yeah, I guess observation.
Yeah. Okay, now what is the y-intercept?
18.690.
Yes.
The slope, did you guys get 12.695?
Yeah.
Okay.
So, sorry, observation, are we putting 139?
I put that
139.
Yeah.
Okay. And I missed the part. Slope 12.695.
Yeah.
What is the predicted value of y when x equals 4?
Okay, so
X equals 4. So the predicted y is 69.469.
I got 69.47.
Okay. Just a rounding. Interesting. Daniel? Oh, Daniel's not there anymore.
Oh, that's weird. There.
Didn't realize that.
I have the work on my computer.
You have what?
The school work, like the.
Oh, okay. Yeah. Well, I don't understand why I get 69.469. I don't understand that, but for X, what do you? Well, I mean, it's the same, 69 or 7. But
yeah, it's the same thing basically. I just use a calculator. That's what it gave me.
Oh, okay. Oh, you're not looking at the spreadsheet?
No, I'm just. Oh, is there a part that talks about? Is there a part that's given in this spreadsheet?
Huh.
Huh.
Hello, Daniel from the darkness.
So I don't know, like the connection. I lost the connection just for the Hangout. Everything else was working.
Okay. We are talking about question 11. What is the predicted value of y when x equals 4?
69.469.
Yes. So is in the linear regression tab, right above the scatter plot, you see that there is confidence and prediction intervals for regression response.
Yeah.
And you have x, and the cell under x, you can change the number there, and if you put 4, it just adjusts to that. I don't know if that makes sense what I said, but
yeah, it's a light blue cell. It's one of those that it's colored.
Oh, right there.
Yep.
16.4. But yeah, I guess rounding it still would be 69.47, right?
Well, no. The textbook was saying that if you do it by hand, it will be slightly different than using the software.
So just do 69.46. Is that what you're saying?
It says 3 decimal. Oh, round to 3 decimals. So.
I hear you. Okay. Makes sense. Makes sense.
Okay. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Not sure I understood the question. So, confidence levels. So we have that the x's are not going above 6. So the maximum y is if we put x equal to the maximum y could be 94.859.
Yes.
So just putting 6. Well, I was just trying to understand, and yeah, it cannot be more than 6 because that's the grade that the students were giving was from 1 to 6.
Okay.
So the maximum y that we can get is putting x as 6 in the same place where you put the 4, just right above the hot dog shape thing, and then you get the predicted y is 94.
4.859.
Yeah.
I got you.
Yeah, because it's like trying to predict the score, like knowing that you get the highest confidence level possible, that is 6.
Okay.
Okay. Question 13. How many explanatory independent variables are present in simple linear regression? How many explanatory?
Isn't there only one of each?
One.
Like one explanatory response?
I'll say 1, yeah.
What do you think, Daniel?
Hey guys.
Yes.
Okay, we're on 13.
Yeah, like.
What do you think about that?
1.
Okay, we agree on that.
It's like the second.
So,
and I would go with the same answer for question 14. Because like a linear regression has just one explanatory and one response, because if it's more, it's a multiple linear regression.
Mm-hmm. Yes.
So a company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes, meaning the company wants to predict size of hat given the circumference. What is the response variable?
Is that which is being measured, right? The dependent?
No, that's the explanatory. Like the one that it's measured, it's like if you think about response, it's the one responding.
So responding,
it's because it's the one responding to something, you know. So it means that it's responding to the explanatory, that it's the independent. So the explanatory is the independent one, and it's the one that we're putting on the x-axis, and it's the one that we're going to measure. The y, it's the dependent because it depends on the x, and it's the response variable because it's the one that it's going to respond to the change in the explanatory.
Okay.
So I will go with the first one, that the size of the hat, because it is the variable being predicted. Because the circumference is not predicted, you know. It says that given the circumference, it means that they're measuring the circumference.
Okay. Quiz?
I am submitting it right now. It's all good. So I think you can stop the recording, Izzy.
Okay.